Okay, so this one, we have to take the derivative of natural log of something, and that's always going to be 1 over that log argument. So I have to do 1 over x to the third power minus 4 over x. So I write it that way first, but I'm going to fix that. Don't worry, okay? So it's always 1 over whatever this log argument is. So I did 1 over this, okay? But you need to multiply this by the derivative of that log argument, okay? So what is the derivative of x cubed minus 4 over x? See, this is a problem, another type of quotient rule problem within a problem. So, all right. So we'll do this red expression and this green expression, and we'll put them together when we are done, okay? So look at the red one first, okay? Look at the red one first. If you are dividing 1 by this fraction, you know what will happen is this. Take a look. If you have 1 divided by a over b, wouldn't that be the same as 1 times b over a, right? Keep, change, flip, right? So over here, you have 1 dividing by this fraction in the denominator. This is the same as 1 times x over x cubed minus 4. So that's how you can simplify this first fraction, okay? Because you have, I'll write it out, okay? What you had was 1 divided by this x cubed minus 4 over x, right? That's what you had. But you can do keep, change, and flip. So if you do that, 1 times x over x cubed minus 4, that just turns into that fraction. So that's what you can do for that red part. Oh, now let's go work on that green quotient rule example, okay? So I'll do the quotient rule on the same line, okay? When you do the quotient rule, it's g squared in the bottom. So g being the original denominator, I'm going to say x squared for the denominator. And let's do the numerator. The numerator goes as g f prime first. G is x. F prime is 3x squared minus, and what comes after that? Fg prime. F is x cubed minus 4, and g prime is just 1. So I think this may be like the very first time I did quotient rule without writing down all my pieces, but that's okay. We've been doing it for a while. I think we're all right. So I'll keep that red fraction for the same for right now because I want to go work on that green one. It's a mess up there. So let's see. If you look at the numerator, what do we have? X times 3x squared. That's going to give us 3 times x cubed. Okay, because there was x to the first and there's x to the second, so they multiply and give me x to the third. Now this part right there, multiplying by 1 doesn't change anything, so I can just ignore that. But let me get these out of this parenthesis at least. Okay, I'll go ahead and distribute this negative 1. So I'll get minus x cubed plus 4. Alrighty. I think I want some more room here. All right, let me make these a little bit smaller. This is more complicated. Okay. So the red one, just wait a little bit longer. Hang in there, red one. This fraction just stays the same for right now. I'm still doing the green one. But if you look at the green, we can combine the like terms now, right? We can do 3x cubed minus x cubed. That's going to give me 2x cubed plus 4 all over x squared. Okay, now look, I may do something over here. X squared means x times x, right? X squared means x times x. Why did I write it this way? I just want to cancel out this x, one of the x, with this x1 on the top. Okay, now let me put the answers together, okay? Here's my final answer. If you multiply the numerator, what is left on the numerator? It's just that. That's the only thing left on the numerator, right? So you will write down 2x to the third power plus 4 on top. Now let's see what's left in the denominator. X cubed minus 4 and 1 of the x. So I'll say the denominator is x times x cubed minus 4, and that's my final answer. Phew. So what made this problem a little more difficult? Well, the fact that we had to use the quotient rule, okay, in the middle of a problem, and also the little algebra that involved simplifying rational expression, okay? All right, let me do one more on the same page. So we have y equals natural log of x is getting raised to the 5th power. Take a look. I will take the derivative of this by bringing down that 5 to the front and have 5 times natural log of x raised to the what power? What's the new exponent now? 4, okay? But don't forget to multiply this by the derivative of the inside part. What is the derivative of natural log of x? 1 over x. So let us simplify our final answer now. We just put these two together. Y prime is a gigantic fraction where we have 5 times natural log of x to the 4th on top, and we have x in the denominator. I don't know, this one was simple compared to the last one, right? Okay, so that's it for these two examples on page 90.